Okay, in this video, we're going to talk about polar, parametric, and vector multiple choice questions, practicing for the AP Calculus BC exam. This is part 2 of 8. I'm definitely doing 4 of them before this year's exam. I don't know about the other 4 because this takes forever. So let's get started. I'm hoping that you've already watched the first one. As I progress through the videos, I'll probably explain less and less and just do more. So maybe the videos will get faster, but like honestly, who knows? So if you're unsure of something that I'm doing in here and you want to see another example of it, there's almost certainly one in part 1 or 2, 3, 4, 5, 6, 7, or 8. Like, there are just examples in all of them. All right, let's go. Question 13, the position of a particle moving in the xy plane is given by the parametric equations x of t and y of t, where dx dt. So here we're being given the velocity, basically. So dx dt is t times sine of pi t squared. dy dt is 30 over the quantity 3t plus 1 squared. The position of the particle is 2, 7 at time t equals 3. What is the position vector x of t comma y of t? So I really like these problems because I really like using the fundamental theorem in this way. We're just rearranging it, right? So we're going to try to figure out where we are at t equals, at t equals, I don't know what we're doing. Oh, we're just finding the position vector in general. All right, so in general, we could say that x is going to be where we are at t equals 3, which is going to be 2, plus the integral from time equals 3, so where we're starting is 3 in this case, 3 to whatever t is. So it's going to be where we start, 2, when did we start there? At 3, and we're integrating until t, of dx dt. So dx dt is here. I'm going to use a dummy variable. I'm going to use u. So u sine of pi u squared, and then du. Now I just fundamental theorem this. This is just like a Calc AB level question at this point. So it's going to be 2, and then we're going to reverse the power rule. So there should have been a 2 pi, so 1 over 2 pi, but also we're getting cosine, so negative 1 over 2 pi. And then cosine of pi u squared from 3 to t. Then we use the fundamental theorem. So we'll have 2, and then minus 1 over 2 pi. And then I'm going to plug in 3 to get, t, to get pi t squared. Then plug in 3 to get 9 pi. And now we just have to simplify this. And then I'm going to go back through and do the same exact thing for y. And we will have our answer. Okay, so this is the t coordinate of the position. Now for y, we're going to do, we start at 7. So it's going to be 7. We're going to go from, we start at t equals 3. So we're going from 3 to t of dy dt, but we have to use a dummy variable. And also I'm going to rewrite it so that I can integrate it a little more quickly. So 3u plus 1 to the negative second. So dummy variable, and I rewrote it to the negative second. Plus 1 times the reciprocal. So that'll give us this. We're going to use the fundamental theorem. So we plug in t, and then we plug in 3, and we get this. And then we kind of expand that a little. So y is negative 10 over 3t plus 1, and then plus 8. So we look for our answer choice, and it looks like the answer is C. So remember, if you want to see something in more depth or whatever, just pause the video, rewind, whatever you need to do. Let's take a look at the next one. X is t squared plus 4, y is t to the 4th plus 3, t is greater than 0. I don't know if that really matters for these problems, but they usually throw that in. We want to find the second derivative of y with respect to x. Okay, so you got to memorize that formula. The second derivative of y with respect to x is the derivative with respect to t of dy dx over dx dt. And then we also have to remember how to find dy dx, which is dy dt over dx dt. And I recommend you find dy dt first. So I'm going to say that y prime, by using the power rule, is 4t cubed. I'm going to say that x prime, by using the power rule, is 2t, which makes dy dx 4t cubed over 2t, which is 2t squared. So that's dy dx, right? So now we're just going to plug into this formula. The second derivative of y with respect to x is the derivative of dy dx with respect to t, so d dt of 2t squared, which we had just calculated, all over 2t. So we find those derivatives, we get 4t over 2t, and that's just going to give us 2. I guess that's why they're telling us t is greater than 0, because if t is 0, you kind of have a problem there. Sort of, maybe not. But anyway, our answer here is 2. Let's take a look at the next one. It's the same basic question, but keep in mind here. So if dx dt is 5 and dy dt is sine of t squared, then what is the second derivative of y with respect to x? I actually think this is a trickier question because they're giving you dy dt. People tend to try to just do the derivative of dy dt over the derivative of dx dt, which would be a huge problem here because you're dividing by 0. But you know, your brain does weird things under stress. So what we need to do is remember this formula and know that there's a dy dx in it, so I need dy dx. dy dx is dy dt over dx dt. So dy dx is sine of t squared all over 5. Now for my second derivative, I'm just plugging into the formula, and I need to actually find that derivative. So the derivative of sine of t squared is going to be 2t cosine of t squared, and then over 5. So we'll get 2t cosine of t squared over 5. That's the derivative with respect to t of dy dx. All over 5. That 5 is just dx dt. So this will simplify down to 2t cosine of t squared over 25, which is option C. New problem. All right. This is a calculator question. So the position of an object moving the xy plane is given by parametric equations. X is cosine of 2 to the t, and y is sine of 2 to the t. What is the speed of the particle when t is equal to 2.3? Okay, so speed is the magnitude of velocity, which is the square root of dx dt squared plus dy dt squared. This is a calculator problem, and there's kind of nothing really to do by hand here. So I'm just going to show you two different screenshots in case you like to do it one way or the other. So I'm just defining something called r of t for like the position, I guess, because usually you use r for position because of like radius, I think. So I defined r of t, and then I found the norm, which is the magnitude of the derivative with respect to t of r of t, and I plugged in 2.3, I got 3.413. So that's going to be our answer, but maybe you prefer to do it this way. So I found the derivative of cosine of 2 to the t at 2.3. Everything sounds like a t right now to me. That gave me 3.369. Then I found the derivative of y of t at 2.3, which gave me 0.71, let's say 9. And then I did the square root of the sum of the squares. So that's a more direct way of doing it, which honestly, that might be the way you're comfortable, in which case just do it. It doesn't make a difference, right? We both are getting 3.413. Let's take a look at the next question. Also calculator. An ellipse is defined parametrically by x equals 1 plus 2 cosine of t and y equals 3 sine of t. For 0 to 2 pi, what is the perimeter of the ellipse? All right, so perimeter in Calc BC is just equivalent to saying arc length. There can be questions where some of the arc lengths are horizontal and vertical lines, so be aware of that, right? If it's a region in the xy plane bounded by the x-axis and the y-axis, you're going to have a horizontal segment, a vertical segment, and then maybe an arc length. So keep in mind there could be those. In this case, it's an ellipse. You're just going straight around. Arc length is the integral from a to b of the square root of dx dt squared plus dy dt squared, or the integral of speed, which makes sense. That's how far you go. If you integrate speed, you're finding out how far the distance traveled. Okay, so that's what we want to do. Again, calculator problem, going to do it two different ways in case you have different levels of comfort with different things. So my first way is I'm defining r of t, which is the position, and then I'm doing the integral from 0 to 2 pi of the norm, which is the magnitude of the derivative of r of t. The derivative of r of t is the velocity, so that's going to get us that. Or I found dx dt, I found dy dt, and then I explicitly typed them in. Also good, takes a little bit longer, I think, but maybe not. It depends on how fast you are at different things. So either way, we're getting 15.865. Let's take a look at the next question. All right. Let R be the region in the first and second quadrant between the graphs of the polar curves f of theta equals 3 plus 3 cosine theta, and g of theta equals 4 plus 2 cosine of theta as shaded in the figure above. Which of the following integral expression gives the area of R? Okay, so now here's the biggest issue for me with this problem is which curve is the one that's like farther out, right? So I have to figure that out. I think we can do this in a sort of lame way where we just say like, I don't know, they're consistent throughout. So let's look at them at pi over 2. So if I do f of pi over 2, I get 3 plus 3 cosine of pi over 2. Cosine of pi over 2 is 0, so I just get 3. And then if I do g of pi over 2, I get 4 plus 2 cosine of pi over 2. Cosine of pi over 2 is still 0, so we just get 4. So g is farther out. So now I kind of know if that's f, it's the inner one, and if that's g, it's the outer one. So I want to do 1/2 the integral from start to stop, which is 0 to pi, because we're just given the region, 0 to pi, of the bigger one squared, so g squared, and then minus the smaller one squared. So we're doing the big area minus the little area. So polar area, remember, is 1/2 the integral of r squared d theta. There's two things you can forget there. You can forget the 1/2 and you can forget to square r. Don't forget either of those. But this will be our answer. Hardest part of this one, which curve is farther out, right? But I mean, looking at the answer choices, there are some very weird, questionable options in there. Like A seems ridiculous to me. B forgot to square anything. A is ridiculous based on the bounds, by the way. B seems weird to me because they didn't square anything. C, they subtracted and then squared. So like, even if you didn't really understand like this figure, looking at the answer choices, D is the only one that really represents a polar area anyway. So I don't know. That's whatever. It's fine. Next question. Calculator again. The graph above shows the polar curves. R equals 3 plus cosine theta minus sine of 2 theta. And r equals 1 plus sine of theta. What is the area bounded? So again, you'd need to figure out which is which. But in this case, I know what 1 plus sine of theta looks like, and it's the tiny one. Also, it's probably the smaller one anyway, because like the first equation has like a lot going on, so it probably gets farther from the origin at various times. But you know, you could like work things out. You could again plug in 0, for example. And like the first curve, if you plug in 0, gives you 4. The second curve, if you plug in 0, just gives you 1. So you can tell that the first curve is farther out. However you want to do that, I'm just going to punch this into the calculator. So I defined the functions. You don't really have to do that. I do recommend it though, because when you're squaring a bunch of terms, it gets tricky with parentheses. And if you make one mistake with parentheses, the Nspire is ruthlessly annoying about fixing that. So I like to define things and then square them. But whatever. We do this, we get 26.7 something. So there you go. A new problem. A polar curve is given by the equation r equals 10 theta. Okay, so the first 20 times I read this problem, I thought it was just 100. It's not. It's 10 theta over theta squared plus 1. Fortunately, if you think it's 100, you don't get one of the answer choices, and then you have to like go back and look a little more closely. So it's 10 theta over theta squared plus 1, where theta is greater than or equal to 0. What is the instantaneous rate of change of r with respect to theta? So you have to read carefully. R with respect to theta. So r with respect to theta, that's dr d theta. So if we're finding dr d theta, this is just a quotient rule problem. So just because it's polar doesn't mean that you're not just doing normal calculus. So bottom, derivative of the top, minus top, derivative of the bottom, top derivative of the bottom, all over the bottom squared. That's what we're doing here. So, I mean, it's a polar problem, but like we're just finding dr d theta. Theta is going to be 2. And if we plug this in, we get, I'm not going to make you watch that. We get this, which gives us this, which gives us this. So negative 6/5 is our answer. Pay attention to what you're being asked. So in polar, you could be asked for dr d theta, dx d theta, dy d theta, dy dx. And you got to know how to handle each and every one of those. And they're all going to come up at some point within these videos. So I don't know, keep watching. All right, new problem. At time t greater than or equal to 0, a particle moving the xy plane has velocity vector given by t squared comma 5t. So that's our velocity. And the question here is, what is the acceleration vector at the time t equals 3? So we have velocity, we want acceleration. Acceleration is the derivative of velocity. On the free response now, they kind of like want you to, they definitively want you to show that. So make sure on free response, you're writing a of t equals v prime, and then just do the work, right? So then v prime, because of the way this is given, I'm not going to like break it down more. I'm just going to say the derivative of t squared is 2t. The derivative of 5t is 5. And so that's our acceleration vector. But the question is, what do we get at 3? So we're just going to get 6, 5. And we get b. Notice like D and E, I don't really know what, I don't know what D is. E, I think, is probably the magnitude of this acceleration vector. D, I have no idea how they would get. No clue. C is if you mistakenly thought you were given the position vector, which I could easily imagine mistaking. So make sure you carefully read the problem. All right, let's take a look at another problem. A curve in the plane is defined parametrically by the equations x is t cubed plus t and y is t to the fourth plus 2t squared. I'll be honest, if it's not a calculator problem, they typically just give polynomials or maybe a little bit of trig. It's not usually that bad, so you don't have to worry about that. You have to worry really about like what does the calculus tell you to do. So these are just polynomials. So y is t to the fourth plus 2t squared. I don't remember if I read that. An equation of the line tangent to the curve at t equals 1 is... All right, so same advice that I've given on previous problems like this. We need to know how to find dy dx, which is dy dt over dx dt. And we need to not confuse x and t when we write the equation of the line. So there's like two problems we have to do before we even like write the equation. We have to find dy dx, and then we have to find x and y. So let's find dy dx. I like to start with dy dt. The reason I do that is because you tend to divide the first thing by the second thing, regardless of what you should be doing. So power rule gives me 4t cubed plus 4t, and then dx dt. Oh, sorry, we evaluate that at t equals 1. So plug in 1, you get 4 plus 4 is 8. dx dt, power rule gives us 3t squared plus 1. Evaluate that at t equals 1, gives us 3 plus 1, which is 4. Overall, dy dx will be dy dt divided by dx dt, so 8 over 4, which is 2. So now we know the slope, which means if you look at the answer choices, we're either going to be picking A or C. But we have to keep going anyway. And also in the videos, I like to do it as if I'm not taking a multiple choice thing. I don't know. I think it's better that way. It helps you like in the long run. But like truly, this is multiple choice. So it's like now a coin flip if you didn't know what to do from here. But we do know what to do. We're going to figure out what x is at 1, just in the equation. So it's 1 plus 1, which is 2. And then we're going to figure out y at 1, which is 1 plus 2, which gives us 3. So our ordered pair is 2, 3, and we need a tangent line. So the tangent line is going to be y minus 3 equals 2, the quantity x minus 2. Always use point slope, and then always look at the answer choices and be like, why don't you write them in point slope? They don't write them in point slope. You know, I'm not really sure why. Maybe that would like highlight more errors that you might have made. Whatever. We got to expand this thing. So if I expand it, I get y equals 2x minus 1. So that's going to be option C. All right. Another problem, we got 2 more in this video, and then I'll be back in another to do more. What is the slope of the line tangent to the polar curve r equals 2 theta at the point theta equals pi over 2? So this is not dr d theta because this is the slope of the line tangent. The slope of a line tangent to anything will be dy dx. It's up to us to remember how to find that. So polar slope of a curve is the same as parametric slope of a curve. It's just going to be dy d theta divided by dx d theta. So we need to know that, and then we also need to know that x is r times cosine and y is r times sine. We need to know that because actually you're asked that question a lot on the free response. Like it'll just be like, here's a polar curve. Find the values of theta for which x equals 3, right? So you just do the polar curve times cosine of theta equals 3 and solve for theta. It's kind of weird that that's a calculus problem, but like that's one of the levels they will ask you about. But we need this information. X is our cosine, y is our sine. dy dx is dy d theta over dx d theta, and let's do it. So y is going to be our polar curve, so it's going to be 2 theta, and then sine of theta. Now I need to find the derivative of this. This is a product, so I'm going to use product rule. So it's going to be first derivative of the second plus second derivative of the first. I need to evaluate this at pi over 2. So the cosine of pi over 2 is 0, the sine of pi over 2 is 1, so this just gives us 2. Definitely know the unit circle values. They're like essential when you're doing these things. All right, x is going to be our polar curve, which is 2 theta times cosine of theta. The derivative is again going to involve the product rule because it's a product. So it's going to be first derivative of the second is negative sine of theta plus second, which is cosine times the derivative of the first, which is 2, so 2 cosine. Evaluated at pi over 2. Sine of pi over 2 is 1, cosine of pi over 2 is 0, so this just gives us something kind of weird, actually. It gives us 2 times pi over 2 times -1. So that's annoying. It gives us negative pi. I mean, it's not really annoying, but it's kind of annoying. So dy dx is dy d theta over dx d theta. So it's going to be 2 over negative pi, which just looks weird to me. I guess, like, there's nothing wrong with it. I just don't like the answer. Okay, there we go. All right, one more problem in this video, and then I'll be back in another video to do more. Here we go, calculator question. The position of a particle in the xy plane is given by the parametric functions x of t, y of t, for which, okay, so you gotta pay attention to what they're giving you. They either give you position or they give you velocity. They go back and forth on that. There aren't a lot where they give you acceleration, but it's also an option. So in this case, we're given x prime is t sine of t, y prime is 5e to the negative 3t plus 2. So we're given basically velocity, the velocity vector if you wanted to write it down. What is the slope of the line tangent to the path of the particle at the point at which... what is the slope of the line tangent to the path of the particle at the point at which t equals 2? Okay, so this is just dy dx. The slope of a line or a curve or a whatever is going to be dy dx. The question is, how are we finding it? We're always basically finding it by doing dy dt over dx dt or y prime over x prime. Gotta remember that. This is a calculator question, so I'm literally just going to type this in. I didn't even store it, even, you know, with all my, I love storing functions. Didn't even seem worth it here because we're just directly doing this. So this is our answer. All right, that's this set of 12 questions. I will be back in the next video to do 12 more. There's already a part 1 that you could watch. Study these, and I think you'll be in good shape. I hope you found this helpful, and good luck.